Alright, so this is a demonstration of this Chapter 7 practice quiz number 1. The first question is actually, I've already gone through in a video. It says, which of the following correctly initializes an array R to contain 4 elements, each with 0 in it? 1 is fine. You can initialize them to 0. 2 works because they automatically initialize to 0 because they're integers. And integers just get initialized to 0 if you're not giving them a value. And 3, I just said it was redundant. You can do it like this, and then they're just assigning it to 0. And so if you go to the array activity number 1, that's where in the sample questions I kind of went through that. And you can read again how you initialize variables up here for ints or doubles or any of them that you need to know about. So 1 is E. 2, it says the following program segment is intended to find the index of the first negative integer where R is an array of n integers. So this one's a hard one. You got to kind of you got to use more logic to kind of think through this. So whenever you're doing these, always create an array that and give it value so that then you can test it. So what I did is I just created an R, and that's equal to I said there's a couple ways to do this. 4, 5, and -3. So it says a segment will work as intended, always, never, whenever R contains at least one negative integer, whenever it contains at least one non-negative integer, whenever R contains no negative integers. So we basically want to find the index of the first negative integer. And so what's hard here is that this program only works if the last number in your list is negative, and I'll show you why. So I is 0. Okay, so we could do right here, I is 0. Let me see if I can. So I is 0. Then we could do something like R at I is greater or equal to 0, and then it does an I plus plus. So the best way is to kind of do something like this. Okay, so is 4 greater or equal to 0? That's true, so it does I is 1. And then, so that's, well, and then maybe do something like this. This is, we want to do our index as well. So this is index 0, this is index 1, and index 2, okay? So at position 0, you got 4. 4 is greater or equal to 0. Then you've got position 1, which is 5. So it's 5 greater than or equal to 0. That is also true. So we add 1 to it, I becomes 2. And then is -3 greater than or equal to 0? That's false. So that doesn't get added up. And then I becomes, that doesn't get added up. Let me think here. So that's not true. So that means that the while loop is done. -3 is not greater than 0. So that means it's done. I was 2, remember? So location is now 2. So it found the index at location 2. So we know that B can't be the answer because we just got it to work. We don't know yet that A is the answer. whenever it contains no negative integers. Well, we just proved that wrong too, because this contains a negative integer and it works. So we've narrowed it down. We've gotten rid of A and E when it contains at least one non-negative. So these are non-negative, so that worked. Whenever it contains at least one negative, so we proved that. So A, C, excuse me, sorry, I'm going to sneeze again. Excuse me. So that A, C, and D are possible answers, but we did narrow it down. We got rid of B and E. So then you got to figure out, okay, well, let's try this now. We'll say R equals and then we'll do an index. So I did 4, 5, -3, and 2. Let me think here. Well, yeah, this would be. So, well, no, this would test out fine too. So we're in index 0, 1, 2, 3, right? We've got an I, and we've got an R at I is greater than or equal to 0. So I would be 0. Is 4 greater than or equal to 0? That's true. So then I becomes 1. Is 5 greater than or equal to 0? That's true. Is -3 greater than or equal to 0? That is false, so then it doesn't run. So A wouldn't work if there's, so like let's just, so this one's fine too, so let's just do another one where we had R equal to 4, 5, and 2, okay, and we had an index of 0, 1, and 2. Okay, if we had I, R at I greater than or equal to 0, so that would be is 4 greater than or equal to 0. It's true. Is 5 greater than or equal to 0. That's true. Is 2. What's that? Position 2 is 2 greater than or equal to 0. Yep. So that would make it 3. And then actually you'd get an error there if there were no negative numbers, because look at I would become 3. Is there anything in position 3? Nope. So you'd have an index out of bounds error there. So it doesn't always work, and it doesn't never work. Contains at least one non-negative. Well, no. If it was all negative numbers, it would just pull out the first one. Because let's say we had. Say we had R equal to, I don't know, -1, -2, -3. Index is 0, 0, 1, 2. Okay, again we'd have I, then we have R at I greater than or equal to 0. And so is -1 greater or equal to 0? So no. So so D doesn't work because this works fine, and these are all negative numbers. It would return 0, the location. because -1 is not greater than 0, so I would be 0. So your answer is C. It just has to contain at least one negative integer. So I think I wrote down a bunch of different possible answers for this, so I'm going to cut that out and put that on the end of, so number 2. And then you guys can kind of go through that if you would like. Okay, so I'm going to save that. Okay. 3, consider the following data field. So you got this whole thing. Which statement is always true about the contents of nums R array after the following call? All values. Okay, so then I just go through and I say, okay, is A is, let's say it's nums equal to 2, 3, and 4. And let's say that n equals 6. So for A, it says all values are less than or equal to 0. So this is 6, so this would be 6 passed in. We would run through the nums array. So is what's at position 0? Is 2 greater than 6? No, so we don't do this. Is 3 greater than 6? No, so we don't do this. Is 4 greater than 6? No, so we don't do that. So all values are less than or equal to 0? Nope, so we proved A can't be the answer. Okay, how about B? I'll say nums is equal to -2, -3, and -4. And let's say n is equal to 6. So is -2 greater than n? No. For B, it says all values are greater than or equal to 0. So -2, -3, and -4 are not greater than 6. So, and since these are less than 0, this never gets hit. So that's the value of it. So all values are greater than 0. Not necessarily. Okay, C. You got nums equal to 2, 3, and 4, and let's say n, in this case, n is equal to -6. So is 2, so for C, all values are less than or equal to n. So is 2 greater than -6? Yep, so assign it to 0. Is 3 greater than -6? Yep, so put it to 0. And is 4 greater than -6? So put it to 0. So all these would turn into zeros, but 0 is still greater than -6, so that proves C wrong. D, all values are greater than or equal to n. A is the same. I could use the same data for A to prove D wrong, because look at, are all these values greater than or equal to n? Nope. 2, 3, and 4 aren't greater than n. So that takes care of that. And so your answer is E. The only one that works is E. Okay, so these, let me cut these out, but all these, let's see here. So for, that's number 3. So, and then for D, C, A. But I'm just going to say all these tests prove that A, B, C, and D are incorrect. Okay, so that's that. Let's see, 4, I'm going to play a video for you. So you've got different types of searches. This first one is a sequential search. So with a sequential search, you would want to do it only if your data isn't if your data isn't sorted properly or isn't sorted, because a sequential search is one at a time. So this is what it looks like. So we're looking for the number 67, I believe, in this list, and so a sequential search searches one at a time. Okay, and this data is actually sorted, so you wouldn't want to use a sequential search. So it finds it on its, 19th try. Bam, it finds it. And so the search would be done. It took 19 steps there. So that's a sequential search. So the question in here, let's just read it real quick. Number 4, in which situation would it be best to choose a sequential search instead of binary? Well, let's see how binary works. Binary, what it does is it basically divides the list in half. And it only can do this because we're doing it, the data is already sorted. It's sorted from low to high. So watch what it does. It finds the midpoint, and then it checks to see, is 41 greater than 67? It's not. So then find the midpoint between index position 12 and 14. Well, the midpoint would be 18. So watch what it does. So then it goes to there, the midpoint there, and then it checks to see, is mid greater than, okay, so they're equal. So that only took 2 steps, where this one took, the sequential search took only 1 step. So you wouldn't want to do, you would always want to do a binary search over sequential, but you can only do a binary search if the information is sorted inside of it. Because think about this, if this was all jumbled up into, and it wasn't sorted, if you divided it in 2, there's no order to this. So essentially you could have 67 way over here. If you divided it by 2, and it did the same kind of thing, you wouldn't know, which way to go, whether you would go over this way to search for what you're looking for or go this way. So it has to be sorted data. So the answer, in which situation would be best to choose sequential over binary? Let's see here. When the data cannot be sorted, A. Okay, so if the data can't be sorted for whatever reason, you have to do a sequential, which would take longer, but that's the only way you can do it, okay? So for 5, consider the method below, which is intended to return true if there is at least 1 duplicate in the array, and false if there are no duplicates. Okay. Notice here we start at 0. And then we compare what's at position 1. Then this goes up by 1, so we go what's at position 1 and then compare it to position 2. This is like a classic AP style question, okay? So A, let's see here. If the array is sorted in increasing order, so let's say we've got for A, we've got nums, let's say it's equal to, oh man, why is that writing everything so large? We're going to do courier, and we'll put it back down to like 10. So if we say nums and it's 2, 3, or 4, or let's say it's 2, 2, or 3, so it's sorted from increasing order. So on this one, if we check this one and compare to that one, is there a duplicate? No. If we compare this one to this one, is there a duplicate? No. That's fine. Here to here, is there a duplicate? Yes. So that would return true. So A is fine. So this is okay. B, and what we're doing, under which condition will the method not necessarily produce the desired results? Okay. B is its decreasing order. So let's say nums is equal to 4, 3, 2, or nums is equal to 3, 2, 2. Again, this is okay because when we compare here to here, that's not a duplicate, so it doesn't return true. That's fine. How about here to here? It's not true, so that's fine. Here to here, nope, but then here to here, yes, that would return true, so that's okay. C, when the values in the array are all positive, I'm going to come back to that one. C is the answer. Well, let's just do it. C, let's say nums is equal to 2, 3, and 2. This is not okay. 2 and 3, those aren't duplicates, and then 3 and 2 aren't duplicates, so that wouldn't return true, but we know that 2 and 2 are duplicates. The problem with the way it's written is it's only comparing the next array element and compare it to the current one you're on. These are all positive, but it still doesn't come out, so this one isn't right. D, what's D say? D says when the values of the array are all the same, so let's say this nums equal to 2, 2, and 2. That would return a duplicate, so that's okay. And then E, when the array has at most 2 elements. So, if we just had 2 and 2, that has 2 elements, and that's okay. So this is the only one, and this is really kind of hard to think through because your test data has to be perfect. But again, this is the type of question that they would ask, so just kind of think it through and keep that on the back burner in your mind, because this is definitely the question that they would ask on a test to see if you understand what it's asking. So that's 5, and I'm going to put that there. And actually I'm going to put in I'll say see this site, because I like this video right here. So I'm going to put that right there. Bam. Okay, cool. So, last one, write the average. Okay, so I put the answer right here. You can look at this, but you should be able to write this out by now. This isn't very hard to do. You need to do a loop that runs through the whole array and then add up the sum, and then all you do is take the sum and divide it by n, which is the number of elements in the list. So that's the answer there. So spend some time on that, but you should be good to go. Make sure you're studying these. And this video is, hopefully I pushed the right button. This video should be done and good to